The universe is a magnificent structure full of vastly gigantic objects and beautiful sights. It's also probably the most terrifying, unimaginable thing that could possibly exist. So here's a few wild things about our universe. According to cosmologists, the universe appears to be flat in shape. Now, what does that even mean? Basically, in terms of geometry, it seems to be that the universe is more like a plane that things are existing in, rather than being a 3D object containing everything. The evidence of this lies in the cosmic microwave background radiation. Scientists discovered that temperatures registered in the cosmic microwave background radiation directly correspond with large structures across the universe like galaxy clusters. They used that information to study how matter is dispersed across the universe. And from that studying, they determined that the universe seems to be flat. If the universe is flat, then that likely means that the universe is infinite and it may expand forever. So we established that cosmologists currently think that the universe is flat. However, this could be wrong. There is a chance that the universe is so much bigger than the observable universe that there is no way for us to detect any sort of curvature. If that's the case, then the universe is likely not infinite, but it is so much bigger than we can possibly fathom. I don't know what's more wild to think about, an infinite universe expanding forever, or a universe that's so unbelievably gigantic, but yet it has an ending point. I'm sure you already know this, but light is really, really fast. It's the fastest thing in the entire universe. This is not breaking news. What's interesting though is that according to special relativity, as an object gets closer and closer to the speed of light, as it continues to speed up, it experiences more and more time dilation. This does not change what an observer of an object moving really fast experiences though. The observer will not experience time dilation if the observer is just viewing an object that's moving really fast. It's the object that's moving super fast that will experience time dilation. What does this mean though? What does it mean when I say that an object experiences time dilation when it's moving really fast? Basically, as an object approaches the speed of light, the amount of time it takes for the object to reach its destination shrinks. The problem is, this only occurs from the object's perspective. So we might see an object take 10 seconds to reach a destination. But if that object is experiencing a lot of time dilation due to moving incredibly fast, from that object's perspective, it might only take 5 seconds. This means that we could calculate that moving at an incredibly fast speed, an object can travel an insane amount of distance, but it will take a long time. But from that object's perspective, it doesn't take much time at all. So if we were to move closer and closer to the speed of light and we go to some super far away object, say another galaxy or something, from our perspective, it might not take that long at all. But from everybody else on Earth's perspective, it'll take millions of years. But now here's the question. What happens at the speed of light? There's nothing. So if a photon emerged directly from the Big Bang, and it still exists as a photon today, that photon, from its perspective, has gone through just an instant moment. Everything has been instantaneous, and if that photon were to last another trillion years, all that time will be instant. From our perspective, it's a very long time. I mean, the universe is 13.8 billion years old, and if we were to assume that this photon lasts a trillion years more, that's such a long time, yet for the photon, it's nothing. Black holes are crazy for a number of reasons, But one of the biggest mysteries about them is what lies at the center. What is at the center of a black hole? General relativity predicts that there is a space-time singularity at the center of a black hole. The problem is, a space-time singularity typically occurs when mathematics breaks down. A space-time singularity, if we were to take it from the literal sense, is a zero-dimensional point, literally like the point on a graph, but it has infinite density. Technically speaking, there could be a physical singularity there. It's not technically impossible, mainly because we've never proven that singularities don't exist, because it's very, very hard to prove that something that we've never seen, never detected, never even been able to imagine doesn't exist. It's very difficult. It's just really, really, really unlikely that it's actually a literal singularity. So as it currently stands, we don't know what is at the center of a black hole. But what's interesting is we can predict what will likely happen if you were to approach the center of a black hole, aside from being torn apart through spaghettification. Gravitational time dilation is where, under the effects of gravity, an object will experience less time. So a long amount of time will pass outside the effects of this gravity, but a short amount of time will pass within the effect of this gravity. Therefore, we can conclude that as you get closer and closer to the center of a black hole, you experience more and more time dilation. So you're experiencing a lot more time passing than an outside observer would. We can conclude then that as you get closer and closer to the center of a black hole, which, as we currently know, it's the strongest force of gravity in the universe, it's a force of gravity that not even light can escape. As you get closer and closer to the center of this, you experience less and less time passing. So technically speaking, the center of a black hole, viewed as a moment of time rather than just as an object, in a way may lead to the end of the universe. If the universe really does have a quote-unquote death date, then being exposed to that kind of time dilation, you will pass millions of years, billions of years. You may quite literally reach that death date in what to you feels like very, very little time at all. That's just theoretical though. There's no real way to test that since we don't have a black hole. And even if we did have a black hole, we still probably couldn't test it. But either way, it's a cool thought experiment. Speaking of time dilation, did you know there's currently a model of the universe that's gaining a lot of traction in the physics community that suggests that the acceleration of the universe being caused by dark energy might actually be an illusion? This model is called the timescape model, and this model suggests that what we perceive to be the speeding up expansion of the universe is actually just us being affected by the time dilation from our galaxy cluster, the Laniakea cluster. That would mean that what we're seeing as the universe expanding faster and faster is really just an illusion being cast by time dilation. Of course, more research has to be done on this topic before any major conclusions can be drawn, but it's a really, really interesting possibility at the very least. Anyways, yeah, the universe is pretty wild. Hope you enjoyed. Please subscribe to the channel. Like the video. Go get a drink of water. Maybe eat some food. I don't know, just do your thing. Bye.